Okay, you guys, the test is Friday, and we're going to do 8-3, 8-4, Monday, Tuesday, Wednesday, review day Thursday. So you should be okay with it. Yes, it's all 10 convergence tests. Yes. It's partner. It's multiple choice. Partner test, multiple choice. What? Yeah. Because, hey, you guys, Will, because all these types of tests that we're doing now is only going to be on multiple choice. It's not going to be free response. So, because that's where they test it, multiple choice. The free response will be the next half of the chapter, and I'll give you lots of practice with that. Matter of fact, I even have a problem for us to work on section 8.4, but it's in the free response part with the ratio test, but you'll see it. Okay, you guys, there. So far, we have only worked with positive terms. All the tests, and I don't have them all up there. I don't know if I can get over in that corner to do that. All the tests we've done so far have to do with positive terms. So now we're going to deal with alternating signs, not negative signs, but they're going to go from plus to minus, plus to minus, plus to minus. We'll have to worry about what happens if they don't do that. Okay, you guys? So the first test that we always do is what? I don't care what, if they're positive or negative, you always take the limit of the sequence, always. Okay, so the first thing I ask you to do here is, can you write that in sigma notation? Now, what's going to make the sign alternate? It's -1. And now I want this, I don't want to start with 1 because that'll give me a negative sign to start with. I want to start with a positive sign. So n plus 1. You have to look at your counter right here and see where it's starting. If it started with 0, that'd be different. And then, which one is this series? It's 1 over what? N, isn't it? Because this is 1 over 1. N is 1, N is 2, N is 3, 4, 5. This is called the alternating harmonic series. And it converges. The regular 1 over n, the harmonic, does not converge. But if the signs alternate, it converges. Alternating harmonic series. Okay, John? Put that away for right now. What's this one? Can you write that one? Starting with a negative sign, so it's -1 to the n. N starts 1, 2, 3, 4, and then this is related to that n plus 1. Now, you look at the sequence, and does that go to 0? This one did. Okay, so we were okay. But the limit of that sequence, the limit of n, as n goes to infinity, over n plus 1 is what? 1. So guess what? It diverges. I don't care if it's alternating or not. It makes no difference. You always look at this. Okay, Grant? If the limit, Grant, Eric, if the limit of the sequence is not 0, then it diverges. I don't care what the signs do. What does this look like? No, it's not geometric. Geometrics are exponentials. What does that look like? Sorry? If you don't want to do it, that's fine. But if I want to add these up, summation of a sub n, starting with n equals 1 to infinity, it doesn't matter which one you want to start with. It just really doesn't matter. So if we start with this one, it's going to be b sub 1. Then what's the sign going to be when n equals 2? 2 plus 1 is 3. -1 to the third is negative, and then this will be b sub 2. Then what's the sign going to be? Plus. It's going to alternate. And then it's going to be b sub 3. Okay? That's called an alternating series. Now, last year on the exam, they even said, I believe, alternating series. They also said that the function was, or excuse me, the sequence was decreasing. And yet, when the students had to justify their response on the free response, they couldn't do it, which wasn't that hard. To be able to do the alternating series test, first, it's got to alternate in sign. It can't just be positive, a couple positives and a couple negatives. Sine and cosine do not alternate, do they? Not necessarily. You'll have to evaluate to find out. Alternating signs. Depends on what happens. Sometimes they do. It just depends on what you've got for a sine and cosine. Then, I really should have put this first, the limit of the sequence without the signs, that's not the negative 1 in there, must be 0. So I always do that one first, because you'll see that it's alternating. But you know what? If that limit of that sequence is not 0, I'm done. And then what this is saying in item A is that the terms of the sequence are decreasing. So the sequence is decreasing. And maybe tomorrow I'll bring in that problem from last year. That's in the spring. Each of the subsequent terms has to be smaller than the terms before it. But all we're talking about is the sequence, not the alternating part. Because the alternating series looks like this. It's negative 1 to the n, or n plus 1, b sub n. These are the positive terms. What makes it negative is that alternating sign. Now, what they did, they even said b sub n was decreasing on the exam last year. All you had to say was an alternating series test. That was it, but it was still missed. Now, I don't know what our students did. I just got the test today, so I haven't looked at it. So I don't know. And it comes into play in the free response when you get a power series and you have to show that you have to look at endpoints and you have to show whether or not they converge there. So you're going to end up with something like this. But all your test is going to be is multiple choice. That's the alternating series test. Okay, guys? You have to have alternating signs. The limit of the sequence has to be 0, and the sequence must be decreasing. You would think that the limit of the sequence being 0, that would force that to always be decreasing, but it's not true. I can't think of one where it's not true, but that doesn't mean it doesn't happen. They're not going to trick you. If you see an alternating series, it's always going to be a decreasing sequence. Now, Grant, you're missing all of this. And you're going to need to say in the free response that the series is decreasing. Sequence is decreasing. You have to say that, though, on the exam. You actually have to say it, make the statement. Okay, so it's not real hard to do. So that's an alternating series. What's the first thing we should do? Find a limit of the sequence. Lizzie, why did you say this is divergent? It's decreasing, but I don't look at that first. I look at this limit first. Why did you say it's divergent? Because this is not 0. What is the limit of that sequence? KR? It's 3/4. Because as n gets really big, if you won the lottery, you don't care about that -1. It's going to look like 3n over 4n, which is 3/4. So it's not 0, so it's divergent. So you're done right before you even start. Okay, what about the next one? It's alternating, right? what's the limit as n goes to infinity of n squared over n cubed plus 1? Is that going to 0? Yes. It goes to 0. And then, what about this sequence? Is that getting smaller as n increases? Is this decreasing? Yes. No tricks. They will be decreasing. So if you get the first two, this is always, I mean, you'll have to look at it, but it's always going to be true. There's no tricks to it. And so then you would say, you would say all of this, and then you would say it converges by the alternating series. You use it in medical engineering, yes. Biomedical engineering. That's chaos theory. It doesn't cure breast cancer. It defines breast cancer. Okay, so what they use, and one of my students came back, and that's what he's studying, and he says they use this all the time. These are just convergence tests. We haven't applied to where they get used. Okay, so we have now 8. I don't have them up there, though. As n gets bigger, you could take the derivative of the function, x squared over x cubed plus 1, but you aren't going to have to do that, so I'm not going to make you do that. But as n gets bigger, aren't each of the terms getting smaller? So if you have 1 over 1 cubed plus 1, then the next term is 2 squared, should put the square in, over 2 cubed plus 1. These are getting smaller, aren't they? No. I'll challenge you to find a sequence with a limit of 0, but it's not decreasing. I know it's weird. I can't think of one. And I probably have one in my answer book someplace. But I'm telling you right now, you're going to be safe. If you have an alternating series and that the limit is 0, it's going to be decreasing. They're not going to trick you. They're not. But you're going to say it's decreasing. Because the theorem doesn't apply unless it's decreasing. And yes, there can be one of these where it's not decreasing. No, it's the only one we have for alternating signs. Then tomorrow, okay, you guys? Tomorrow, we'll find the error in this. Because you're not going to add up an infinite number of terms. You're going to add up a finite number of terms. How many terms do you need to be less than a certain error? And that's what we're going to do tomorrow. Do absolute convergence and the ratio test, and that will be all 10. And you'll have them all. You need to know them all. Your packet for 8.1 through 8.4 is due on Friday. Remember, that's your study guide. It's 30 summative points. However, they have to be done well to get all 30 of your points. It's due Friday because that's when your test is. Okay? Now, there's a writing assignment. I was going to have it due tomorrow, but I can have it due Wednesday. There's a writing assignment. So you can turn it in. I have it due for tomorrow. Due for tomorrow.
Study guide 30 points to Friday. Did we already receive this?
Yes, it's the blue one. Well, you did. You can get another one if you launch it. Tuesday. Now, the rest of the time, you need to work on those purple sheets. And I've got to get your quizzes. I think I left them in the other room. I got to go get them.